There are a few different kinds of factoring problems, so I've got a couple of examples here of the two basic types, and then something we do with factoring problems at the end for a third example. In this first problem, where there's no number in front of the x squared, it's just implied to be a 1. I can do this a little bit easier than normal. I just go straight into my two sets of parentheses, and if this does factor, I should be able to get two numbers that multiply to give me 12 but add to give me positive 7. So what I like to do is write down the number I want to multiply to get and list out all the combinations of numbers that will multiply to give me 12. So like I've got 1 times 12, 2 times 6, 3 times 4, and then all the negatives. Negative 1 times negative 12, negative 2 times negative 6, and negative 3 times negative 4. Because a negative times a negative still gives me a positive 12. Now on a third column, I want to see what I get when I add each number in the pairing. So 1 plus 12 gives me 13, 2 plus 6 gives me 8, 3 plus 4 gives me 7, and there's the number I want, so that's the pair of numbers I want. Notice I can keep going, but these are all going to be negative when I add them, and I don't want a negative 7, I wanted a positive 7, so I use this pair of factors here, the 3 and the 4. Since they're positive, I put plus signs in front of them. So x plus 3, x plus 4 is my answer to the question, what is this factored out? Now I can always check myself if I'm unsure by using the FOIL method or the distribution method, whichever way you're used to from Unit 3, where we say x times x is x squared, x times 4 is positive 4x, x times 3 is positive 3x, x 3 times 4 is positive 12. Combine my like terms in the middle. I end right back up at where I started. Now, since the FOIL method resulted in the original problem that I started with, I know that this is my factorization. When we have a number in front of the x squared, we have to do a little extra maneuvering first. The first thing I want to do is take the number in the front, multiply it by the number at the end. So 2 times negative 3 is negative 6. Now I want to go through the same process I went through in the first problem. I want to find pairs of numbers, every pair of numbers that multiplies to give me negative 6. Well, I could have 1 times negative 6. I could have negative 1 times positive 6. I could have 2. There we go. I could have 2 times negative 3, or I could have negative 2 times positive 3. And that's all my pairs of numbers. I've exhausted everything as far as getting negative 6 goes. Now I go through the process of adding each pair until I find positive 5. So 1 plus negative 6 is negative 5. Negative 1 plus 6 is positive 5. There it is. So negative 1 and negative 6 are my factors. Now I can't go straight into the factorization like I did in the last problem because of this 2. So what I need to do instead is rewrite the middle 5x as a sum of the two factors that I found in this step here. I took the 5x and split it into a negative 1x and a 6x, the two numbers I found in finding my factors. So now instead of having 3 terms, I have 4, 2 here and 2 here, that I'm going to factor by grouping. Now, factor by grouping, I look at this first pair of numbers. The only thing I have in common as far as anything I can divide out is an x. If I divide an x out of the first pair, I get 2x. If I divide the x out of the second number, I just get 1. I've taken the x out. second pair of numbers, I can divide both numbers by 3. So 6x divided by 3 is 2x. Negative 3 divided by 3 is negative 1. My two sets of parentheses match, which is an important thing. If they didn't match, I would have to go back and see what I did wrong, or I couldn't factor this problem. Since they match, the matching set of parentheses, that is one of my factors. 2x minus 1 is a single factor. The other factor is the pair of things we divided out, the parts that are in front of our parentheses, x plus 3. Now again, I could distribute this back out to check myself, but I know that this is going to work. So those are the two main types of factoring problems as far as trinomials go. Either you have a number in front and you have to turn it into a factor by grouping problem, or you don't have a number in front and you just go straight to the factors by listing all the factors of the last number that add to give you the middle number. For this last example, we take one of these two types of problems and it has an equals 0 at the end, or sometimes it'll have a different number over here, but I always want this to equal 0, so I just have to move my extra stuff over to the left hand side. So what I want to do with this is start out by factoring this piece the same way I would factor either this or this. Since I don't have a number in front of the x squared, I'm going to use the method from my first example and come straight to my sets of parentheses. I know x times x is what's going to give me the x squared. I look at the last number and write out all pairs of numbers that multiply to give me negative 16. I could have 1 and negative 16. I could have the negative 1 with the positive 16. I could have 2 and negative 8. I could have negative 2 and positive 8. I could have negative 4 and 4, or I could swap the negative sign, but it's still the same pair of numbers. Now that is every pair of numbers that multiply to give me negative 16. I want their sum to be the negative 6 from the middle. So 1 plus negative 16 is negative 15. Negative 1 and 16 makes positive 15. 8 and negative 2 gives me negative 6 when I add it, and negative 6 is what I wanted. So I needed a positive 2 and a negative 8 to FOIL that out and give me a negative 6 in the middle. So I've done the factorization. The one added step to this type of problem is taking each factor and setting it equal to 0 and solving it on its own. So since I have two factors, this and this, I'm going to have two answers to what x could be to make the original problem equal 0. For this problem, I'm solving it just like I did back in Module 1. I'm just trying to get the x by itself. So in this case, x equals negative 2. And in this case, x equals 8. So when I go to put these answers in, I just put the two answers in with a comma separating them. There are times when there will be a number in front of the x squared, and you'll have to factor it using the method from example 2 here. But the end step is the same. You take your two factors, set them both equal to 0, and solve. And those are the three main types of factoring problems you have. If you have any other types that I didn't give an example of in this particular instance, just email me and we'll make another video with the examples that you need.